Welcome, everyone. Great to have you here today. I'm Jenny, the community manager. As we wait for people to collect today, feel free to unmute your microphone, turn on your video, introduce yourself. I saw many new names on the list this morning, so feel free to say hi, and we will get started here in a few minutes as we let people trickle in. Anmol, hi. You're welcome to say hi.
Hi, Jennifer. Hi, Jennifer. Hi.
Introduce
Thank you
yourself.
so much. Yeah, so I am a PhD student and I'm doing double PhD at Indian Institute of Technology, Roorkee, India, and University of Groningen, Netherlands. And like we have started a startup also recently, and we are working like kind of a medtech startup, and where we are using computer vision to solve to identify like oral cancer in India, particularly. Like there is a different reason altogether for oral cancer in India, which is chewing of tobacco, like excessive chewing of tobacco and cigarettes. So I was like looking for continuous ML and uh, like ML ops whole system. That's when I discovered DVC and iterative.ai, and I thought like I should join the meetup so that I get a chance to know you guys and maybe a bit in the whole process, get involved a bit in the whole process. And I really like the way iterative is like and its offerings. CML, DVC, and everything like yeah. So we are going to integrate DVC in our whole workflow for the start. Yeah.
Awesome. Great to hear. Great to have you here today. We'll look forward to you presenting at a meetup next time or sometime soon.
Sure.
Does anyone else want to say hi from who's here? We have some team members, and I was just saying, so Rob up here, the one with Rob and Alma, this is the first time we've had two people in one camera. So you guys want to introduce yourselves?
Hopefully not last. Yeah. Hi, everyone. Yeah, I'm Rob. I'm one of the developer advocates at Iterative. So writing blog posts, going to conferences, the likes. And I brought Alma.
Yeah, I'm Alma. I'm Rob's partner, and I'm a data scientist at a small scale-up in the Netherlands. It's a mobility and transport scale-up, and we're actually now kind of starting to explore what machine learning can do for us. So this will be a really interesting talk for me to see what challenges that also might bring.
Sammy, did you want to say hi?
Hey, I'm Sammy. Can you hear me all right?
Yep.
All right. Well, I've been lurking around the DVC community for what feels like a couple of years now. Read your paper, Nadia, enjoyed it. Looking forward to seeing what you have to say and what useful insights I can glean from this so that I can whip my data scientist colleagues into shape. So yeah, good to see everybody.
Cool. Thanks for being here.
Yeah, I hope we'll have a good discussion if people are reading the paper. Nice.
I read it. I'm prepared.
I also read it. It was great.
David, introduce yourself too.
Yeah, I am David. I work on the DVC team as a software engineer. And previously I was a computer vision researcher. Reading the paper felt like a flashback to my old problems. I think it's a really good paper. Thanks for doing it.
Thank you for the appreciation. I see it. Well, so it always feels good if people read your work and appreciate it, and we can have a good discussion in that end, right? So it's not me just discussing things over you and giving you ideas what can happen. I also looking forward to know your feedback on it, know how you're feeling about it, what challenges you have faced, you have experienced in your project. So yeah, it will be great.
Cool. I think we have time for one more introduction. Alex, you just came on camera. Would you like to say hi?
Hi, can you hear me now?
There it is. Sure. Go ahead.
So hi, my name is Alex. I work in a consultancy company as a data scientist in the UK. My name is Elements Talent. And I'm a data scientist there. I'm working on actually a project using machine learning to basically utilizing machine learning and data analytics to help senior stakeholders make recruiting decisions.
Okay.
And I'm really enthusiastic about today's talk.
Cool. Awesome. All right, well, let's get started. Everyone, if you are coming in, I'm Jenny, the community manager. Today, we are really excited to have Nadia Nahar with us presenting. She is a PhD student at Carnegie Mellon. She and her team worked a year on the research she is sharing with us today on collaboration challenges in building ML-enabled systems, communication, documentation, engineering, and process. She will be making this talk interactive using Slido and some QR codes, so you may want to have your phone ready for that. Also, she's going to utilize at the bottom of the Zoom screen, you can see the reactions button down there. If you hover over it, she'll be utilizing that. So be ready to give some reactions during her talk. And I'm really eager to hear about what she has to say, and also everything from you guys afterwards, what resonates with you and all the stories that you guys have to share. So with that, I will turn it over to Nadia.
Thank you so much. Let me share the slides first. Can you see it?
Yep.
Okay. Presenting that. Okay, so yeah, thank you, Jenny, for the introduction. And as I was just saying that it's not just about me telling you guys what my experiences was. I'm also looking forward to learn from you. What were your experience in the similar categories? What did you face? What the challenges that you face when working on this kind of machinery systems? So yeah, I hope it will be a good interaction. So a brief of introduction. Oh, sorry. Yeah. Before introduction for myself, as Jenny is saying, that I'm working as a software engineering PhD student at CMU, and I have been working on this software engineering for machine learning research for about more than 2 years now. So yeah, trying to figure out different parts of challenges and this. And I have also some experience in working in MLOps in Microsoft when I was working in deep learning inference service, but yeah, not as much as you guys have. So yeah, I will not try to give my expert opinions on that. So I'd like to also know about you a bit. So I'd like to start with knowing that what were the roles that you identify as yourself. So I have 4 roles here, like are you a software engineer, a data scientist, a machine learning engineer, or a unicorn who knows in depth about all these engineering and data science things, like know it all someone. So you can just scan the QR code, go to slido.com and just use the ID however you feel it's good. So just try it out and let me know that what are the roles I'm seeing here in the audience. Wow, I see a lot of different background people. So it's always good to have interdisciplinary audience as well, because it makes a good discussion, because you're from different backgrounds, you can have different perceptions of the same thing. So it's always good to have this kind of people. But yeah, I see there's a lot of machine learning engineers here. Nice. There's some software engineer, data scientists, and I can see some unicorns as well. Wow. Unicorns are rare. Okay. Yeah. So yeah, this most 50% of the people are machine learning engineers. Okay. That's great. So I'll go in the discussion and we'll come back to how these roles can have different parts of challenges based on which kind of companies you're in. Okay, so I'd like to start off with a bit of a discussion from the machine learning in software products perspective. I know you guys have much more better understanding than me on working on this field in practical, but just bear with me because I'll have a complete different view of these products or ideas. So in this slide, you can see that I have a Python notebook code in face detection where you can just put some images and have the face detection as an output in the image like this. But is this a complete product? We cannot say the product, right? So it's just a model where we can train something and have some output like that. But if we want the end users to be able to use this model, we have to put this in some kind of product where the users can interact with this. The users can have these outputs, the predictions in the user interface and in different forms, right? So, and common usage of this kind of models is like Google Photos. So I use Google Photos in everyday life. So you can see that Google Photos have different kind of models like object detection, face detection, face recognition. And I really like their feature of these, that where I can just select myself and see all the pictures I'm in, and select some of the other people I know and see, find the pictures of them with me. So this is a practical usage of this kind of models. And there's also like different models. As I said, there's a model of object detection where you can just put some pictures and it will detect the objects in the picture with some confidence score. And we can use this again practically in different kind of products. A common usage of this in the safety critical autonomous cars, when the cars have to detect the objects in the street so that it doesn't crack with any of the objects that is on the street just laying around. So my point is here that we often build a lot of different models, but what we have to do is to make the end users use it. So we have to help them use the model. If we want to do that, we have to wrap it around a product and make it useful for them, just not like provide some notebook code and just show them the results like that. So for that, you guys have always been seeing this data science pipeline, I'm sure, like more than I don't want to go into the details of this, but it's just that in the data science pipeline, we have a lot of focus on this data collection, cleaning, feature engineering, and model training and evaluation. But all we often know that the scripts that we write for data cleaning for the model, the machine learning code, is really a very small, tiny portion of the entire model deployment. So as I can see that there's a lot of machine learning engineers here, you guys know well that there's a lot of other phases for this. We have to manage the resources, we have to manage the process, the infrastructure, the configurations, and many different tools to just deploy this small, tiny portion of machine learning code. So when we started to realize that, we had more focus on MLOps that we have right now, because we try to understand the importance of the phases of the model deployment and model monitoring, and we know the importance of them now. So we're trying out full pipeline automation, we're trying out MLOps with different clouds, scaling up, and this kind of facilities. But what I want to pitch in is that still, even if we have all these, this whole component is still a component of the entire product. So it's not the entire product itself, because the product have many other different parts in it. There's a user interface management. If you remember about the Google Photos app, it has a lot of different components other than the machine learning model that have to interact with the machine learning model, so that we can use the prediction that the model is making. We can provide it to the outer world. We can take the inputs from the outer world and provide it to the model. So there's a lot of interaction between different components, which are not all machine learning components, which are different engineering components. And I'm not saying it's that just one component. Of course, it's the many machine learning components, and there's a lot of different components that have to successfully interact with the other components of the system to make this product successful. So what I have seen so far is that we have come out from the model view a bit. We have come out from the notebook view, but we're still mostly in the pipeline view. We are still thinking about it, how we can serve the machine learning model, and that's where we just stop thinking about the product anymore. So I want to pitch in here that we still have to think about the entire product view, which is very much neglected in practice. And there's many discussions around it in different blog posts, forums, that how we have a really large number of machine learning products that doesn't make to production. And on many of the problems, we found a lot of collaboration issues that I'm going to discuss it more. And then we have issues because we have like different kinds of stakeholders working in the same product. And if the machine learning model does not serve the goals of the product, then we cannot use it. So for example, if I make a model that makes prediction have a very high accuracy, it provides like 99% accuracy, it doesn't matter, because if the product goal is to make it the prediction fast, if I want the predictions in a few seconds, if it's taking 10 seconds to make the predictions, then the prediction is not of any use for me. So there's often also discussions about how the data science trajectory is completely different than the software engineering one. Previously, we had traditional software development where we have typical stages and typical phases with which the project managers can think about the timeline, their project planning, the estimations, and so on. But now with inclusion of machine learning, we need more time for exploring. We have to go for multiple iterations and see if this model is actually working or not. So this completely different process is also making us fail to integrate these two different genres of people. So I have seen frustrations in Twitter as well, where people often complain about they didn't understand the business context first, which is why the project failed. And also like we are doing a bad job in both science and engineering in both the parts. So there's a lot of discussions around those as well. So now I'd like to know from you, and I know that you have worked on many different projects in your life. So can you remember about 1 or 2 projects where it didn't go to production because of some problems that you had? And can you describe it in like 5 words or so, just in a small sentence, so we can have some discussions around it? Exactly. I can see an answer of SIPMOL business rules did better than a model. Exactly. Sometimes we don't really understand that where we should fit a machine learning model and where we can just solve it by some rules, some just software engineering, simple rules. So it's really important to understand if we're applying a model in it, will it really bring something in the product? So that's really about the business case. Will it really have something? Okay, I can see a lot of problems. Wow. Okay, failed A/B test, problem of integrations in the dashboard. Yeah, that's a very common thing that we see. Oh, manual classification is cheaper. I cannot agree more. Data used for training not available. Yes, we see a lot of skew in the training data and the data in the real world when the model is finally deployed. That's a really, yeah, I can see another sentence on that as well. Yes, this is a very common thing in the training data model where we think the real world is idle place, and when it's not, we try to blame our machine learning model for that, but we have to understand we train the model with idle data and we're not getting idle data anymore, right? Faulty collection pipeline, yeah. Wow, I can see a lot of issues that you have faced. So yeah, I feel you guys, and so I know it's not, we cannot solve it everything in one day, but at least I can help you to think from some challenges perspective, and many of these issues that can be solved by some small like themes that I'll show you later. I can see unrealistic expectations. Yeah, that's I have heard from everyone in the industry, to be frank. Like everyone faces this problem, that the clients, the managers, even sometimes the software engineers doesn't understand what the machine learning capabilities are, and they have a lot of unrealistic stuff like 100% accuracy demand, that kind of things coming. Flaky stakeholder, badly scoped. Yes, it's very important. The requirements is very important, which I'll go next. That if you do not understand what the product is scoped on, and then you do not have a good agreements on what you want to do, and the stakeholders just keep changing their mind, it's going to be like, it's not going to be a good product. Even if you can deploy something at the end of the day. Wow, I can see a lot of issues here. Nice. So yeah, I will move on and then we can discuss more on this stuff. And I'm really happy to see so many responses from the participants. It really makes me feel good as a presenter all the time.
Yeah, well done, guys.
Good job. Okay, so a lot of the issues that you have been talking about, I'll go on this. It seems like many of those are really dependent on working with multiple people. So you need to have team effort for many of the things. I'll show you how. So as I have seen that in this audience also, we have many software engineers, data scientists, and machine learning engineers. to say it in one line, we cannot do it alone. It's not possible for us, the software engineers, or us, the data scientists, to just make a product by our own, because the engineers, they have a different set of expertise. They know the best engineering practices. They know how to make a product. So we need to use that expertise. And again, data scientists, they have a different set of expertise. Like they know how to make a good model. They know what kind of data they have to train the model on. So which the engineers cannot do. So all these people, even I can see that I didn't have space in the slide. So there's many other roles that I have kept in the bottom of the slide: the data engineers, the domain experts, the operators. So there's many different people involved in building this kind of system who cannot really do it alone. They have to work together as a team to make this kind of system happen. So we can discuss about that. What if we have unicorns who are equally capable of doing data science, engineering, who are domain experts as well? But let me tell you one thing, that unicorns are really rare. I've seen there's some unicorns in this audience as well. So it's really rare to have this kind of people who have in-depth knowledge about everything. And even if we find unicorns, it's very difficult to afford them. I don't know who is the unicorn in this audience. I don't know if the companies in the mid-sized companies, their startups, even if they can afford you guys. So this is not an option. So the option that we have is to build interdisciplinary teams. The teams with both software engineers, data scientists, machine learning engineers, and everyone working together as a team to build a product, not just focusing on small parts like just the engineering parts or just the model parts, just focusing on the entire product thing. So in the industry, I have seen many different ways of team formation. So this is a picture from my paper, if I've seen it. So you can see in organization T, we have some teams where the product and model team are actually an integrated team, where both the data scientists and the software engineers work in the same team and build the product working with each other. And we have also seen organizations like Organization 7, where the product team is completely separated from the model team. So with product team and model team, I'm meaning that the product team is the team who is thinking about the entire product, who is building all the engineering parts. And the model team, I'm talking about the teams that are building the model, who are more focused on the model part. So this kind of model teams have mostly the data scientists in it. And you can see that there's some engineering expertise in some of the data scientists. That's how they try to build some APIs and provide it to the product team, and and the product team just uses that APIs to get the predictions and build the product on it. So there's many different organizations like this with different informations. But what we have seen, that most of the problems that these people face are in the boundaries between the team, where the multiple teams are collaborating, trying to exchange different stuff like the prediction, like a documentation, where there's a lot of conflicts between this kind of team. Even if there's a single team, like in organization 3, you will see that there's many sub-inner groups where these data scientists are really working in silo, even if he or she is in part of the entire team. So there's many conflicts around that, how these people collaborate together. So this is why we wanted to study this. We wanted to know what are the collaboration points and what are the challenges that these people are facing when trying to work together, or trying to collaborate with each other. So that's why we did an interview study. We had 45 interviews in 28 organizations. And there were many different types of participants, some machine learning related, some software engineering related. But what our main focus was on, to have multiple people from the same team and people from different expertise. For example, hiring a software engineer and a data scientist from the same team, and talk to them and learn about the different perspectives they have on the same thing, right? So that's why we talked to many different people from the same organization, 45 people from 28. And we also did it go globally. We have talked to people in Asia, in America, and Europe, and all over the globe, to just have a perception from all the different locations that companies are in. And in company type, we focused mostly on non-big tech companies, because big tech companies are really different. They have different ways of working, different infrastructure, different kind of frameworks that they use. And the non-big techs, the mid-sized companies, the startups, even the big companies with non-IT genre, they also have, they're also facing a lot of challenges trying to deploy this kind of machine learning models. So we wanted to focus mostly on those kind of teams. But yeah, we also did talk to some big techs as well to get their perceptions on this as well. So if I want to summarize everything in 3 words, it will be just everybody has complaints, like everybody. No one was happy with their team. The software engineers, the data scientists, everyone was complaining about the team, the collaboration patterns, the team members, the managers. So everyone was unhappy with their team. And I cannot show all the stories in this single presentation, but I'll try to give you some idea of what kind of complaints came up. So I'll start with an example of a company where they were trying to do a warehouse forecasting, and they hired data scientists in the company to just build a model to forecast how many products they'll be needing in a certain time. And the data scientists had to talk with the logistic team. The logistic team was the main people who was working the model, who was using the model to know the forecasts. And they were a marketing team on which the data scientists were dependent on, because of based on marketing campaigns, he or she also had to make sure that the model is providing more forecasts than the regular times. And the marketing team was also dependent on the data scientists, because based on the forecast, they'll have to do marketing campaign or not. And there was IT teams who who were responsible for helping the data scientists on the infrastructure, on any kind of IT problems that he or she faces. So in this situation, I heard many complaints. I'll show you a few. So one was that the data scientist told me that I was always struggling to change the mindset of the team lead, convincing him to hire an engineer, because I had to learn a lot by myself. For me, it was fine to learn. I just didn't want it to be my main responsibility. So there was frustrations from the data scientist perspective that he or she couldn't convince the manager to hire an engineer to do the engineering parts of the model. So it was really frustrating. And even I heard that the manager finally hired someone, and it was again another data scientist. So there was no engineers hired even after he or she shared a lot of frustrations on that. And then there's also issues where she told me that we wanted to ask the data warehouse team to provide data, and it was really hard to get resources. They wouldn't do that because it was hard to measure the impact for our in-house product, had the bottom line of the business. So the main thing was that so the person wasn't able to make the other team members understand that the model was important in this, how the model was making a business impact. And that is why he or she wasn't finding supports from the team member, wasn't getting enough data from the team members. So that was a huge problem for this kind of system, these kind of small companies. And when I also talked to the big techs who didn't have any problems of resources, they had company resources, they had human resources, but still when I was asking about the team members, the one response was like this, that there were people who are machine learning engineers at the company, but they don't really understand ML. They were actually software engineers. The way they work on ML is just by using the existing infrastructure. They don't understand overfitting, underfitting, and dash. They just copy paste code. So these again came up from another machine learning engineer who was really frustrated on the team, who didn't have a good understanding of machine learning. So this is like so you cannot think about that it's just a problem of a small company or a big company. The problem is everywhere. So if you don't hire machine learning engineers, there's a problem. If you hire machine learning engineers, there's a problem. So you cannot really hide from these issues if you do not fix it. So we also had a lot of complaints on clients, product managers, software engineers on AI literacy. Just as some of you guys told me earlier that there was problems of unrealistic expectations. So it was so common. I heard about it in every company I talked to. So one instance was that a person told me that for this particular project, the project manager wanted to claim that we have no false positives. And I was like, well, that's not going to work. So this is the situation where the managers, even the software engineers, expect you to provide a model with 100% accuracy, which is definitely not possible. So yeah, I can keep talking about all the stories that I heard, and these are really like horror stories. So these 45 interviews were really frustrating. But what I want to do now is that if you can think of what we can learn from these stories, how can we mitigate this kind of situations? So what we tried is to group these problems, what kind of problems they're facing, first trying to find the collaboration points where they were facing the issues. So we found 3 main collaboration points where people are facing most of the challenges. One was requirements and plannings, where there is a lot of conflicts while trying to gather the product and model requirements. I'll go deep down in that. There's also many issues on project planning, where it's really hard for the project manager to estimate the timeline of the project now or plan for the project because there's uncertainties involved in the machine learning part. So that was really frustrating for many of the project managers. Then the next collaboration point is training data, where we heard a lot of frustrations around how they couldn't get good quality data, they couldn't get enough quantities of data, and there was problems in the power structure in the organization. They were not able to get the data team provide them with the data they wanted. There was problems of having static mindset that you just have to train a model once and it will be good for the lifetime, which doesn't happen. You have to keep feeding the model data. There was a lot of issues around that. And the third collaboration point was product and model integration, where there was a lot of cultural clashes, not having a good responsibility boundaries where you try to integrate product and model together. There's a lot of frustrations around who have to do the testing of the model, who have to do the testing of the product. There's a lot of conflicts on that as well. And we found 4 themes. These themes were basically the reasons why these problems were happening. And also we can think about some solutions on those based on these themes. So there was lack of communication. There was rarely any documentation. There was not enough engineering appreciation in this kind of systems. And there was also a lack of process. We don't have a good process for this kind of machine learning products. We need more research in this area to figure out what will be a good process for this kind of machine learning products for to feed in the software engineering development phase. So let me go deep down into one of the points here, product and model requirements. So I feel this is very important. This is why I kept it here, because this is the first part where you start thinking about the machine learning in your product. So when so in these collaboration points, we have to involve the clients, the management, the product team, and the model team. Again, as I said, I'm just making it simple. The product team has the software engineers and the model team has a data scientist. It might be a different formulated team, but just to keep it simple, to check how they interact here, I'm keeping it like that. So there were many different patterns around different organizations. I'll give you examples of 2. So the first kind of organization is when you have a banking software and you want to detect some frauds in that banking software. So the flows of the requirements is something like this, that the management and product team first sits together and comes up with the product requirements that, okay, they have to build a banking software and they will have these modules in the software. And the product team and model team then sits together and the product team tells model team, okay, you have to provide me with a module where it can detect the frauds that's happening in that software. And then the model team works with the data team to get the data and the process goes on. So this kind of flows we call as product first trajectory, because the product was there first and then we decided to include some models in it. So in these situations, the problems that we have faced, that the management, the product team, when they sit together, they don't really have understanding of machine learning. So as a result, the product team often commits to the management that, okay, we will have a module which will be able to detect all the frauds that's happening in the software. And as I already said, that 100% accuracy cannot be ensured by any machine learning models. So when the product team then talks to the model team that you have to provide me a module like that, a machine learning model that will be able to detect everything, the model team says that it's not possible for them to build. And that is where the conflict starts. That is where the model team faces the difficulty of convincing the product team that this cannot happen. And as this is like later in the process, the whole product, the whole success of the product is also at stake. So we find 2 problems in this particular example where there was a problem of communication because of the not having enough email literacy, the product team and the managers could not come up with the realistic requirements. So one recommendation here is to involve data scientists early in the process. Even if you're thinking that it's just the product part, we haven't come to the model part, we need to think about that the product also have the model capabilities and we need to set correct expectations on that. And the second thing was documentation. Most of these requirements were transferred verbally to the model team, and there was no written agreements on that, which is why there was a lot of issues afterwards, because you cannot just say that, okay, you told me as an agreement to this and I didn't agree to this. There was no written evidence of that. So that is why we say that even if you don't like documentation, I know no one likes documentation, but you have to keep it, because it have to be as an agreement of what you wanted to build and what you can build, what you cannot build, so that this kind of conflicts can be mitigated. And the second kind of organization is organization B, where they have to develop an OCR, optical character recognition, for a local language. And in this kind of company, there's a completely different flows of work. As the OCR is the main module, which is the model part, the model team gets into the authority, and the model team management and clients sit together and decide about the model requirements. And later, the model team just hires a product team to build a wrapper around the model and provide it to the end users. So the issues we have, we call it a model first trajectory, as the model was there from the first. And the issues we find here is that the model team still have to educate the client and management, but it has way less impact, because the model team is already in the discussion, and this team can talk to the client and management from the beginning and try to set the right expectations that they have to have. But the main problem here is that this kind of trajectory doesn't have focus on the product. As a result, we have seen a lot of problems that even if the model is working very well, when the product is not good enough, when you don't have a good user interface where the clients can easily interact with the system, the clients were really unhappy about the product. So there's a lot of complaints from those perspectives that, okay, the model works good, but what if I cannot even use the model in the product? So there was many issues around that side. So there was still the problem of communication, because the model team still have to educate the clients on that, but it was had less impact. And we see many teams that had these recommendations to just conduct training sessions, which mitigates the problem a lot. If you conduct training sessions for customers, in product teams, and software engineers before the project even starts, they'll start to understand what machine learning can do and cannot do. And the main problem was the problem of process, because if you don't really think about product from the very first, it really seems problematic that you cannot, because the product is the one that the client will interact with. So on this, we again think about, you have to keep both model team and product team when you are deciding on that, and you have to emphasize more on this collaboration point. And we don't have a good process. Let's just admit that we don't have a good process on this kind of machine learning models yet, machine learning products yet. So we have to come up with a good process on that. There's a lot of research needed on that part. So yeah, apart from the product first trajectory and model first trajectory, we also had a third trajectory, with parallel trajectory, where the model team and product team would work together the entire time and communicate with each other and comes up with the more product. But this trajectory we didn't see it to scale, because this was just small teams who had the ability to talk all the time and just come up with the entire product working together. So which might not be possible for the larger companies. So yeah, this was the 3 patterns that I found in requirements. And now I would like to know from you, which of the product trajectories do you think the project has followed? So for this, you can just try to put the reactions in Zoom. So you can, for product first trajectory, you can just say yes. For the model first trajectory, you can say cross. And you can, in the parallel trajectory, you can say faster, something like that. Can you see the reactions in Zoom?
So yeah, the reactions are, if you hover over the bottom, there's like a little smiley face that you guys can react with. But so product first trajectory, there's only so many emojis here. So what would that be? A thumbs up? And model first trajectory,
Oh, I can, yeah, I can already see some ticks here in the participants.
okay, they've got the checks going.
Yeah, you can also, yeah, you can just, if it's easier, you can just use thumbs up for product first.
No, that's good. Stick with that. Just don't confuse everybody. Sorry. Yeah, so you can click on the ellipsis and you can choose the other emojis.
Yeah. Okay, previously I saw that those emojis comes up first, but yeah, I'm not seeing it. Yeah, I think you're having a hard time to find those, but thank you for still answering this. I can see many people have worked on product first trajectories. Nice.
Well, we've got one with model first.
Yeah. Yeah, I also feel that so in the product first trajectory, it's very common when you have a like large product and model is just only one functionality in the entire product. So it's very common to just go for product first trajectory. But mostly the model first trajectories occur when you have we don't have a model existing model from previously. You have to come up with the model yourself. And so it's like the iterative process when we do the risky parts first and then we build a product around it. So in those situations when the model is the main part, we often see that they often start with the model and then wrap around a product around it. So yeah, let me just move forward. So I will jump to the third collaboration point here. So let me tell you that the second one is also really important. Training data has a lot of challenges and a lot of complications in collaboration. But I heard that this audience is more interested in product and model integration. So that's why I focus mostly on that. But I also have some bonus slides on training data. We can continue discussions after this presentation as well, if you'd like. So yeah, let me move forward with the product model integration. So in product model integration as well, we found 3 collaboration patterns. I'll go on those one by one. The first one I found was shared model code, where the model team is responsible for only developing the model, and they just provide some training notebook codes to the product team, and the product team is then responsible for both deploying the model, doing the operations, and also often integrating it to the main product. And we have seen that in these situations, the product team just have to sometimes rewrite the training code in the pipeline as a pipeline and then add it to the product and do all the other stuff that they had to do. So the pros of this kind of trajectory is that the model team doesn't have to do any engineering responsibilities. Doesn't have to know about the engineering. Doesn't have to do about anything on the engineering. So it's just that they can really emphasize or focus on the model part and don't have to think about the other parts of the system. But let me say that's problematic. So you can see there is a clear boundaries between the model team and the product team, and as a result, the siloing of the data scientists happen here. So as the data scientists are siloed now, they don't understand the business context. If you remember the problem that was mentioned in the Twitter, so they don't understand the business context and they're building something that might not fit with the product goal. So if I remind you about the discussion, about the discussion on the forum, that they have like different expectations than the product goals. So as a result, when they build this kind of model and the product team tries to integrate that, they find a lot of integration issues with the product. And there's also, if as these teams are completely divided, there's a lot of different cultures in these 2 teams, and they have a lot of conflicts around that. They have a lot of conflicts on code quality. So the product team says that the model team's code is not good, they're not following any engineering practices, and the notebook code doesn't have any comments, so that the product team doesn't understand what it's doing in this phase and so on. And that's why the product team gets really frustrated on the code given from the model team. And also the model team is often frustrated on this, because when the model team provides the notebook on the product team, sometimes the product team cannot really replicate the performance and efficiency that the model team was getting from the notebook code. So that's when the model team says that, okay, I built a model and the product team just completely ruined it because it's not as useful as when I built it. So there's a lot of issues around this. And then the second pattern that we face, that is model as API. This is the most common pattern. Actually, we found 18 organizations was following this pattern. And in this kind of integration, the model team has the responsibility of both developing the model and deploying the model. And typically, they just create an API and provide the API to the product team. And the product team just uses that API to interact with the model and get the predictions of the model. So in these situations, the model team requires both the engineering skills and the data science expertise. And an ideal case would be when if the model team has both a software engineer and the data scientist, or some engineers on that perspective, to just build something on the model. But we have often seen that it's not the ideal world. So in many situations, only the engineers are trying to do some modeling and trying to build a model and just provide some API to the product team. And we have also seen in many cases there were just data scientists who built the model and then was trying to figure out how to make the API. Somehow they're learning the engineering and just providing an API to the product team. So in this situation, both this like in the cases when there's only engineers in the model team or there are only data scientists in the model team, both of these teams always get so frustrated on that. Okay, I'm not doing something that I'm assigned to do. I'm doing something else. So yeah, there's a lot of frustrations there. But the pros here is that as the development and deployment are both handled by the same team, they understand this, the system better. And this same team have closer collaboration. They can sit together, they can talk and discuss how it can be deployed well. And there's always like easy to just communicate within the inner team. But the problem is, I say, that the team members are often assigned to so many undesired responsibilities. If you remember the story that I shared with you, where the data scientist was not really happy about the responsibilities assigned on the engineering part. So it happens a lot in this situation where the boundaries between the responsibilities are not assigned well. And the third pattern that we found was all-in-one, where it's often we have seen that the small teams just have one integrated product and model team, where this team have all the responsibilities. They have to do the deployment, development, integration, and everything. So again, an ideal case would be to have a mixed team with data science and software engineers or machine learning engineers. But we have seen that it's just sometimes only the data scientist trying to pull this off, trying to build something around the model and just provided something to the clients. So again, the pros here is that there's close collaboration among the team members, having less conflict on that. But again, the cons is that the responsibilities are not assigned well, and this kind of teams doesn't scale well because they're just small teams with small responsibilities. But if the teams starts to get bigger, we have seen that the subgroupings happen again. So in those cases, again, the data scientist is siloed and the engineers are working together and they're not communicating well. And again, that kind of problems keeps arising. So now I'd like to ask you again that which pattern do you think your team have followed when you were building a system, a model for system or a product for system that we were building before? So you can again use the same tick, cross, or fast forward button to answer it. Okay, I can see one person was using model as API. Model as API. I can see shared model code. Shared model code. Oh, there's some all-in-one as well. Okay. Yeah, so in these situations, we have seen that most common is model as API because it's really easy to divide the product part from the model part. But yeah, as you say, there's a lot of problems around that as well. If you're not having the team members who are actually expert on engineering, who are actually expert on data scientists, there's a lot of frustrations on that as well. Yeah. So yeah, on any kind of teams, as I said, there's many different kinds of team here. But if I want to give some recommendations in this part, one thing would be to first define the processes, responsibilities, and boundaries before starting developing the process, developing the machine learning product. And then to have a documentation of the API. So I know that no one likes documentation, of course, I understand. But when there is like different teams, when there's different types of teams, different expertise there, so you have to give documentation so that the people doesn't always have to come reach out to you directly to understand what is happening in this notebook. So we have to keep documentation on that part. Then I must emphasize here that you have to have engineering support, and I'm really happy to see Generative AI providing different tools for engineering support, the DVC, CML, and these kind of tools. These are really needed in this kind of system because you cannot do everything alone. You have to have engineering support in this kind of model deployment, monitoring, data validation, and so on. But most importantly, I think that if you establish a team culture of mutual understanding, if you try to understand each other in the team and understand the differences, and then it will be really easier to build this kind of products, just having better communication within the team. So to summarize, the first thing first is that we have out from the model view, we have to come out from the pipeline view, and we have to think about the entire product. There's a lot of different engineering pairs alongside with the model. We have to think about that. When we start thinking about that, we will see that we need many different experts in here, and we have to work together, build an interdisciplinary team, foster the collaboration between these different people, and then give extra attention to the major collaboration points where we are having most of the challenges right now. So yeah, that will be it. So yeah, Jenny, I'll go for the discussion right now. I just wanted to give a follow-up question here. If you can think about any collaboration challenges you have experienced the most, just one word on that, any of the challenges you have faced here, and we can go for the discussion from here.
Cool. Yeah, let's do that. And I'm curious about what challenges people face, and then also like from our community here, who has found solutions to any of these things that have worked for them and their teams.
Exactly. Yeah, that's another way to frame it. Yeah, if you have better recommendations for all these challenges, all these teams, that will be really useful for the other teams who are facing the challenges. I can see a lot of posts in the chat.
Yeah, responsibilities. That seems
Mhm.
it seems like there's sometimes when you have people siloed and they're coming from different areas that they don't even understand what should be their responsibilities in the first place. So even if they do their best, they're just going in different directions.
Exactly. Many people are emphasizing on communication. Yeah, I definitely agree with that. It's always collaboration is all about communication. And we have seen so many issues because of just the problem of vocabulary, just a problem of terminology, that we don't understand each other's vocabulary well, the data science engineers, and they're trying to talk about something. And I always give this example on performance, that for engineers, for software engineers, the performance really means the response time. And for data scientists, performance means accuracy. And as a result, when you're talking about performance, you guys are talking, but you might have completely different assumptions in your mind that what are you talking about. So yeah, that's really important. Responsibility is getting much emphasized, and operationalization, exactly. It's really hard to operationalize any model after the monitoring phase. Maintenance comes from the similar idea. Reproducibility of experiment from the data science I was replacing. Okay. Okay. Yeah, reproducibility is really important. Politics is there. A lot of issues around ethics, politics. This will be eternal. You will keep having issues on that.
Yeah.
I can see a lot of chats here. Is there any questions on me on here? Jenny, can you help on that?
Yeah. So, and who would like to share? Does anyone want to share some of their experiences, and certainly any solutions that can be helpful? I did have one question as I read through your paper, and I totally understand the focus on more of the middle selection, which is more where there's more people about, but you did have a small group of big tech interviewees that you had. And I was wondering, like, what were some of the solutions that they maybe arrived at, because they've probably had a longer process of this and have more people, and did you get any insight of solutions to these issues from those?
Yeah, so on the big techs, one thing that I realized is that they really have some good established processes. So they have a built infrastructure from before. When someone from a new team comes and tries to use that infrastructure, there is documentations on that. You can understand the infrastructure and easily use that. But also, of course, in big techs, I have found that people still complain about documentation, not understanding the infrastructure much like they should have done. But yeah, there's one very distinguished feature was that they have an established framework for everything. So if you think about monitoring, the mid-sized companies and the startups are trying to build up something by themselves to monitor the models. But in BuildX, there's these practices already established that how we can monitor in. There's teams for doing A/B testing and other monitoring stuff. So there's really, so they have, I'd say that some responsibilities already assigned to different teams for different parts, and with the focus is mostly on how this machine learning model can sustain. So how it can become retrained again and again, and it have to keep on the monitoring step and so on, which was really rare for the mid-sized companies and startups that who just the mindset was to just try to build something and provide it to the client and get done with it. Which was not an ideal process. I'd say that machine learning model, of course, for that you have to keep feeding it the training data if you want it to keep working, right? So that was a common distinct I found.
Cool.
I'm seeing a hands up from some.
Sammy, why don't you go ahead?
Yeah, I just wanted to it seems my video is frozen, but can you hear me?
We can hear you.
All right, cool. I wanted to clarify something that I interpreted from what you said about the three different types of teams, or the deployment strategies. You have the like models API, or everyone's working together kind of thing, or the shared model code. It seemed like maybe you were suggesting, or it was your impression that the all-in-one team structure was you didn't really seem to care for that very much. And I was wondering if you could speak a little bit more as to why that is, because it seems to me that one of the biggest problems, I was the one that put politics in there as the challenges. One of the biggest problems I've encountered is people like negotiating for power, right? Political capital, by saying, if we own this, then we can make the decisions. And it's just like, I don't care. I don't care who says I own the thing. Can we just build a good thing, please? And I think that the way that you get rid of that, at least it seems to me that one way to get rid of that is to tear down that wall where it's like, oh, my team owns this thing. No, it's just us. It's just us, and we're building it, and there's no, So I'm wondering if you could speak a little, if that, what thoughts does that strike in you and the rest of the attendees?
Yeah, so all in all, as I said at the beginning, there's no team. I didn't find any team who was doing very well on any of the, but everyone was having issues on different types of issues based on their team management. But as I say, that all in one, I found can be applied mostly when you have a small team, a small number of people in the team. So when the team gets bigger, it really gets hard for them to have a good communication way to talk to different team members. So all-in-one was working well when you have a team of like 4, 5, 6 people who can sit together in a room and talk about the machine learning model and the product. But when you have a larger product, we haven't really found many teams that are just one single team which have this much of people. You have to have many people, and you have to just break the people, group the people based on their experiences and expertise and so on. So one issue was definitely that it was not possible for the big teams to have all-in-one teams. But if, as I said, if you have a all-in-one team, it gets really easier to just communicate and see it and have established a common team culture for that team entirely. So that gets really easier. But it's also that when your team gets bigger, as I say, there's subgrouping happening. Again, you will see that there are inner groups, and those inner groups really represent the other team patterns that I've talked about, like the share code or the team code as API. Because in that big team, I have seen that the data scientist is again working as silo. He or she is working on their own, trying to build something, just get something on like a training code in a notebook and just provide it to someone, some engineer in the team, and the engineer will again complain about this because they are not really working together, even if they are in the single team. So we have seen many things like that. But that's definitely a point that if you can make people work in close collaboration, things start getting better. But we don't have good opportunities to make it, because if you have many people in building the same product, we cannot really have one single team where everyone can work together and build something. So that's for sure.
Cool. We had a question from David. He asked, are you planning to checking in with teams from the paper later in the future to do follow-up research?
I have checked in with the people in the paper already, because when I was trying to come up with this paper, I first wanted to make sure that the results really represent them. So when I had the first draft of the results, I first sent an email to all of the 45 participants, and I got their validation that if they think that their team that I mentioned that this is the participant P set 17A, so is this correct for them? Are they really from this trajectory, or are their working ways really this that I have understand from the interview? So yeah, they replied to me. Some of them had tiny differences that we mitigated, and many of them were really okay with whatever result we have found. So yeah, I did follow up with them, but I am not thinking about another interview study right now. Yeah, so if that answers your question.
So a lot of work, a year's worth of work, yeah, but a very good work. I'm gonna pause here for a minute because we're like at time of what it's supposed to be. So I just want to respect people's time. If they do need to go now, we'll extend a little bit longer, because there's good conversation happening here and I don't want to cut anybody off. But I just wanted to say if anybody needs to go, I've put some links in the thing. And with that, we will continue on with Alex has a question. I find it super interesting that this all comes down to a people problem. Like we have to find ways to work together that makes sense. And it's super important for the amount of impact that AI is going to have going forward. Like these are challenges we have to definitely figure out.
Exactly. Yeah, I'd like to emphasize on the people problem here that Jenny just said, that it always comes up to people problem. It's us. We cannot work together. It's not the technology itself. We have to think about some ways for us to working together.
I did have one question I asked Slido. It ties into the follow-up research maybe, but were you able to validate the recommendations you provided? Would they work?
That's a good question. So some of the recommendations actually came from some of the teams. So different teams were working. Different teams were facing different problems, and they also had solutions in different parts, for which they're not facing a problem of that will not completely devastate their product and so on. So many teams, for example, the recommendation I provided that having training sessions for the customers and the product teams, it was actually taken from a team who was applying it, who figured it out that it was an easy way to make them understand about the model before they just jump off and do the model work. So some of the recommendations actually came from different teams who were not having that much problem on that area. But for many of the recommendations which we provided based on our understanding of the situation weren't really validated, that I would say. But yeah, you can definitely try that out and let me know if that worked for you. But yeah, as many of the solutions were actually people solutions, so it's really difficult to validate if it's working or not. But yeah, feel free to just let me know if any of the recommendations have worked for you on your project.
Cool, thanks, makes sense.
All right. Well, thank you so much, Nadia. This was amazing. It was an amazing presentation. I think we all got a lot out of it. Thank you for your research that you did with your team. This was clearly a lot of work and thought and passion going into this. And it's so helpful to the entire MLOps community in general. Things to think about and how we can all get better. So thank you so much for being here.